Hello student, we have seen the kinematics and dynamics part of uniform circular motion. Now let us see motion in vertical circle, that is also part of dynamics of uniform circular motion. Now motion in vertical circle is an example of non-uniform circular motion. Everywhere, whenever a particle is rotated in vertical circle, suppose a particle is attached to one end of a string and string is rotated in vertical circle, then everywhere in the vertical circle we'll observe the speed of the object is not constant. So speed of the object is changing in vertical circle. So that is example of non-uniform circular motion, because in uniform circular motion everywhere the speed of the object is constant. So motion in vertical circle is example of non-uniform circular motion. Now as the particle moves in vertical circle, we'll observe two things. One, the speed of the object as the particle goes up in the vertical circle, the speed of the particle decreases and tension in the string also decreases as it goes up, because both the speed of the object and tension in the string depends on the value of theta, and as theta increases the value of cos theta is increasing from +1 to cos 180 degree -1. So let us see, as theta increases the speed of the object and tension in the string both decreases. So let us see the different situation in vertical circle, motion in vertical circle. When we give the speed of the particle at bottom with different speed is given at the bottom most point of the circle, then we'll observe in some cases the particle oscillates in lower part of the vertical circle, in some cases the particle moves in upper circle and then it leaves the circular track, and in some cases we'll observe the speed is enough at the bottom, then the particle is completing the motion in vertical circle. So let us see the motion in vertical circle and the three different situations of vertical motion, right? So motion in vertical circle, we will start. So let us take, this is a circle, let us take, and this represents the center of the circle, and a particle with the help of a string, a particle is attached here. Let us take a mass is attached, and this mass, this length of the string is L, and this is with the help of the string this particle is rotated in this vertical circle. Now let us take at some situation in vertical circle, if we give u speed at the bottom, let us take this angle is theta. So when particle is reaching from A and it reaches to, let us take point B, the string makes theta angle, and let us take at this point the speed of the object is given by v, and I can say this value, let us take v theta when the string makes theta angle, and we'll observe this part is nothing but, since this is L, so this will be L cos of theta, and this height h can be written as L minus L cos theta. So I can write L, and this value is 1 minus cos theta is the value of h. Now when the particle is reaching at B, making theta, the string is making theta angle, let us take the tension in the string is given by T theta, and the speed of the object is given by V theta. Now we can write down V theta square, the speed of the object at point B, can be written as the speed at the bottom u square minus 2g, because against the gravity it is going, minus 2g h, and I know the value of h is nothing but it is L 1 minus cos theta. Is it clear? And I can also write down the tension in the string T theta. The net force acting here is T theta, and then if you take the component of weight here, this is mg, I can say, and in this direction the component is mg cos theta. So I can say T theta minus mg cos theta is the net force towards the center, and the V theta is, so the centripetal force is V theta square, V square by L I can write down. Now so the tension at any angle theta can be written as mg cos theta plus m V theta square by L, and you will observe this expression can be written as mg. When we replace the V theta by this value, I can write mg cos theta plus m v square can be written as m by L. V theta square can be written as m u square minus 2 gl 1 minus cos of theta. Is it? This value. So I can say the tension at theta angle can be written as mg cos theta plus m u square by L minus 2 mg plus 2 mg cos theta. So 2 mg cos theta, 3 mg cos theta, I can write down m u square plus L plus 3 mg cos theta minus 2 mg. Is it clear? Is it clear? I can write down this value. Is it? Now if I take three situations, suppose the particle has to complete the motion in vertical circle. The particle, let us take the particle has to complete motion in vertical circle, right? Now you will, two things you will observe here. First thing, v theta, as theta is increases, the value of cos theta you will observe is 1 at theta 0 degree, and it is cos theta is minus 1 when theta is 180 degree. So you will observe as theta is increasing, the value of cos theta is decreasing. Now when cos theta is decreasing, this will increase. So once this will increase, the v theta will increase. So I can conclude here as theta increases, v theta decreases. And what about t theta, the tension in this thing, that also when it decreases, this is positive, so this value comes down. So v theta decreases, also t theta decreases. Both are decreasing. Now if the particle has to complete the motion in vertical circle, then you will observe the particle has to complete motion in vertical circle, then nowhere I can say, v theta should be, v theta and t theta should be 0. This should be more than 0. Then only it can complete the motion in vertical circle. Now if I say v theta is not 0, then let us find out the bottom speed. Now if v theta is greater than 0, then I can take this value u square at top let us take v theta is greater than 0 at top, then I can say u square minus 2gl and 1 minus cos theta at top, cos of 180 degree. Is it? This value should be greater than 0, and you will observe from here u square minus 2gl and then 1 minus 1, yet 2 should be greater, or I can say u should be greater than root under 4gl. Is it? From this expression, u should be greater than 4gl, then only v theta is not 0 at the top. If u is less than root 4gl, then v theta will be 0. V at the speed at top will be 0. And if t theta is greater than 0 at top, then from this expression I can say mg cos theta plus m by L u square minus 2gl, 1 minus cos theta is minus 1, 180 degree, should be greater than 0. So minus plus, so minus 2gl. So this value I can say is minus mg plus u square by L, and this value minus 2 mg, where is the, right, this expression, sorry, this is not the expression, we'll take this expression, t theta is not 0. So this value, if t theta, this expression, let us take this this expression. You will observe cos 180 degree at top, it is greater than to minus 5 mg, or I can say if t theta is greater than 0, then I can say m u square by L minus 3 mg minus 5 mg should be greater than 0, or u should be greater than root under 5 gl. So what we observe here, two speed at one, if bottom speed is given root 4 gl and bottom speed is given root 5 gl. Now when I give 4 gl, then speed is 0 at the top, and when give root 5 gl, then tension will be. So I'll take the higher value, because if I give root 4 gl only, then tension somewhere it will be 0 in the upper vertical circle. So the minimum speed at the bottom which is required to make the vertical circle is root under 5 gl, and if it is more than root 5 gl, then it will continue in vertical motion. So first situation I can say the u is greater or equal to root under 5 gl, then only it completes motion in vertical circle. Otherwise it will leave somewhere now if u speed is given. Now if let us say root 5 gl, if I say root 5 gl, u is root 5 gl, then I will observe the tension at top will be 0. Is it? And the speed of the object can be written as root under gl. If you just see the expression, you can find out tension 5 gl is given. You can see from this expression 5 mg, and this will be minus 5 mg, so it will be tension at top will be 0. And speed can be obtained from this expression, from this place. You can find out the speed. Speed will be your root gl, right? If you give bottom speed as 5 gl, then now if I take this value, if suppose it is less than, now you will also observe when it just completing half of the vertical circle. Now the second situation I will take when u is greater than root under 2 gl and less than root under 5 gl. In that situation, the particle is reaching in the upper circle at this place, and somewhere, if speed is less than root 5 gl, somewhere tension will be 0. And then whatever the speed will be particle, this will be moving in vertical, projectile motion will be there. Now, if particle, the third example I'll take, if your bottom speed is less or equal to root 2 gl. Now, in this situation, we'll observe the particle oscillates between, suppose this is D, this is E, between D and E. Is it clear? So three situations are there, and what are those three situations? The three situations are, when, let us summarize it, let us make a summary for this one. If you take summary, let us see how to summarize it. Let us make three speeds of bottom, three types of motion in vertical circle. Let us rub all. Let us rub all, and then we see face. Now the three situations for motion in vertical circle is three situations. The first situation will take the bottom speed is less or equal to root 2g. Let us take three situations. Three situations. What are those three situations of motion in vertical? Three situations. First, when the bottom speed of the particle is less or equal to root 2gl. Right. Now let us see what happens. Now when I take, this is center, this is L length, and let us take at bottom, the speed is given as root 2gl. We'll observe this particle reaches just horizontal up to this point and then comes back, and then it goes in this one up to this place. In lower half of the circle it will be oscillating. Now when you give root 2gl, the value of V at this place is 0. I can find out tension at bottom here. T, I can write down T minus mg is equal to m u square by L. I can write m 2gl by L. I can write tension is 3 mg. Is it? And the speed at this place, horizontal level, it will be 0. Right? And tension here will be also 0. Right? When you give speed equal to root 2gl. And if it is less than root 2gl, then it will be oscillating in lower half of the circular track. Now second situation I'll take when u is greater than root under 2gl and less or equal to root under 5gl. Now in this situation, we'll observe the particle goes in upper circle, and somewhere here tension is 0 and the particle leaves the circular track. So somewhere in vertical circle, the particle leaves the circular track. And third example we'll take when speed is given greater than root 5gl, then we'll observe this completes the vertical circle, and at the top the V can be given as root gl, and observe tension at this place will be 0 at top, and tension at this place at bottom will be 6 mg. Right, so this is what happens in case of three situations. Here the particle oscillates, here it leaves vertical circle, and here when it is greater than and equal to root 5gl, particle completes vertical circle. So this is all about motion in vertical circle. Now the same situation is there in case of circular track. Now their normal reaction in place of tension, normal reaction will come, and nowhere if normal reaction is 0, then particle will be completing the motion in vertical circle. So there if you give bottom speed as root 5gl, n will be 0 at top, and then the particle speed at the top will be root under gl or gr, you can say. Thank you. If you like this video, please subscribe the channel.